Hi everyone, this is Navid Madanian. In this tutorial on Unreal Engine 4, I'm going to go through some issues inside some standard macros done by Epic Games, loop macros actually. I found some issues there, and I'm going to show you what those issues are and fix them. So let's go to Unreal Engine. Here's a very simple and actually empty blueprint. We just have a billboard. These are standard loops. First of all, I need to apologize you guys for my English, and I'm going to show you what the problem is. Here I have a for loop, and I have set indexes from 0 to 9. And let me just show you, run it and show you what the issue actually is. Come here. I'm going to print the index corresponding to loop body and the index corresponding to the completed execution pin, and see what happens. So let me compile it and just play. As you can see, oh sorry, what is this thing? This here, right? Let me just run it again. As you can see, the 0 to 9 indexes are corresponding to the loop body, and the 10, which is showed here in red, is actually comes from this execution pin, this complete execution pin, and this is wrong. Why? Because we have only 0 to 9 indexes, and this standard for loop, this index actually output corresponding to the completed gives me the wrong index. Yes, there are 10 loops from 0 to 9, but actually this is not the loop counter. This is this local integer here is the loop index, because when the loop starts, actually it assigns its value from the first index, which means if I assign my first index to 20, this is going to start from 20. So this is not the loop counter, this is the loop index that comes out here. So for the completed, we have this issue that it actually shows the index number 1 more than our actually final last index, which is wrong. But for the loop body, it gives me just the correct index. Let me show you the other loops and see whether do we have this issue here or not. For the loop with brick, we have the same issue as well. For the loop, for each loop actually, which is corresponding to an array, we do not have that issue. And let me just show you. I have set up a very simple array here, which is consisted of 10 elements. I have assigned 0 to 9 random integers to them, to this array, and per element of this array we are going to have a loop. And let me show you the result. This is going to print out the index, not the elements corresponding to that index. And this is right, we do not have 10 here, and this the index corresponding to the completed is just right, because I have 10 elements, but the element indexes starts from 0 to 9. So this is right, and the same thing goes for each with brick. You can by holding down Control and left click, you can grab a link and from one node and just plug it into another. Okay, let me show you this one as well. This is going to work just fine, as you can see. Okay, but let's go up here and fix the issues we do have in for loop. Actually, the reason we have this issue here is that, consider I have set first index to last index from 0 to 3. The thing is, when it gets to 3, it checks if the first index comes in, it's 0, and it checks if the 0 is less than or equal to 3 in our case, and yes, it's true, so it's going to fire the loop body, and at the same time increase the loop index, the lookup integer here, increase this value by 1, and then check it again, and so on. But the thing is, when it gets to 3, actually it comes here and say 3 is less than or equal to 3. Yes, it's correct. So it's going to fire true and goes to loop body, and at the same time assign it to 4. Here where the problem happens. 4 comes here and checks it. Is 4 less than or equal to 3? No, it's not. So it's going to give me false. It's going to fire false. And the problem here is that it has assigned the local integer to 4, which is one more than 3, and it hasn't reduced it here. And that index corresponding to the completed is going to give me one index more than my actually valid range of indexes, which is 1 more than the last index, which is 3 in our case. So okay, we can solve this in 2 different ways. But to show you why we do not have this issue inside the for each loop, let's take a look at for each loop. You may say, hey, we have a less than here, not a less than or equal. So this is what makes it right. But no, actually this is not. Because this is not a loop. This is an array loop. Actually, this loop runs per array elements. For loop, let me just put them in order. For loop with break. Thing is, for loop I can assign 0, and 0 is going to be a loop for that. But for each loop, 0 means that the length of the array is 0, which means that we do not have any element. So we cannot have any loop for that, because the array is empty actually. So in fact, the length should be 1 more than the array, the array index value. And which it means that this less than here is actually equal to this less than or equal here. But the reason that we do not have that issue for each loop is this extra local variable we have here. This makes it right. This guarantees that even for the completed execution, the array index corresponding to that is going to give me just the correct value. The way is that actually in this graph, it does not directly increase the array index, but it increases the loop counter, the extra variable here. And if it gives me true, it's going to assign it to the array index. If false, it's not going to assign that, so I'm going to have the previous array index. It's not going to increase that, so I will have the correct value here. So let's go back to for loop. So we can solve it in 2 ways, the easy or the hard one. Actually, the Epic Games has chosen the more difficult way to solve it. We can do it way easier. But first I'm going to do it the way that Epic has done. So I'm going to add another variable here, and let me just name this variable. I'm going to name it the loop index. I'm going to call this extra variable, the loop counter. Okay, I'm going to assign just like the loop index. I'm going to assign the first index to loop counter. I'm going to check not the loop index but the loop counter here. Oh, come on. And actually I'm going to increase loop counter. I'm going to increase the loop counter here. And if success, I'm going to assign a loop index to loop counter. Okay, I think this should work. Let's check it. Okay, save it, and okay. Actually, I did it inside the standard macros. I didn't plan it. Let me change it later. Just check it here and see if it works. As you can see now, I have the correct index here, and this is right. Actually, I forgot to do something. I First, let's find this standard macro here and make a copy of that, and it named it macro, so this is correct. This is what I want. I don't want actually to make the changes into the standard macros done by Epic here. I want to create a new macro here, and I'm going to apply the changes here. So I'm going to add the for loop with break in the array for each loop and for each loop with break. I'm going to do the changes here. So actually this is how you can solve the issue, but there's a way easier way to do that. I'm going to just go back to the default, to the previous setup, and I'm going to remove that, and plug it here, oh come on, and here again, here, and this is the previous setup. So I'm going to save it again, and I'm going to now go to standard macro 2, and here I'm going to apply the changes. Oh, yeah. this one, plug it here, this one here, there. Okay, this is the standard setup. That is the wrong step actually, but there's a way easier way to do that, and that is very simple. Instead of adding an extra variable here, which is going to make this value correct index, I'm going to just have an assign here, node here, and I'm going to decrease the index, because actually this false tells me that we are in the we are not in the valid range of the array the indexes, loop indexes. So it means that we are one above it, because it's going to increase it by 1. So I'm going. All I need to do is to just decrease the loop integer value, which is our loop index, and subtract it by 1. This is correct, and this should give me the correct value. Actually, now I need to first name them. Name it for loop 2, name it for loop with break 2, and name it for each loop 2, and for each loop with break 2. Okay, I'll save it. I'm going to the blueprint and actually replace it with the one I've just created. Search for loop, and for loop 2. I'm going to grab it here by just holding on Control and I said left clicking. You can grab a pin and just plug into another node. So I don't need this one anymore. Let's check it here. This means plug into the event begin play. Setting indexes from, for example, 0 to 9. Now let me compile and play it. Okay. Yes, this is correct. So it's simpler to do that this way. Now let's go to the for loop with break. I just took a look at for loop with break here, and I noticed that this branch here actually is so weird. Why do we have this here? This is wrong, this is useless, and I'm going to tell you why. The difference between for loop with break and simple for loop is that we have another condition here, which tells me that we have received a break execution, and we must leave this loop at once. The problem is that, well, what this branch, this if condition tells me is that the true tells me that we haven't exceeded the valid range of the loop indexes. We are inside. This is going to give me true, and this true tells me, and I haven't received a break condition. I have received a break execution, a break order. So the condition is perfect, and the thing is, in this if, which actually comes from this true, it does not make any sense, because this is going to again check out that we have received a break condition or not. Well, of course we have not, because otherwise we shouldn't be in the true path, we should be in the false. So actually this false is never going to fire, it's never going to happen, and actually this branch is useless here. I should go ahead and just delete it. It doesn't do anything. Actually I don't know what this branch exists here. Delete it here again as well. The thing is, this not actually, what does this not does is that this does not change the current state of this boolean. This not actually change its vision. It says, for example, we have received a break. It's going to assign it to true, this local variable. This not says that if this local value is false, the not says, yes, it's false, but you consider it as a true. Just consider it. If it's true, it tells, yes, it's true, but consider it as a false. It does not change the current state. It just shows a different state. It does not change it. So this is actually not a function. You can look at it this way. This is a liar. This is always going to lie about the Boolean state. If it's true, it's going to tell you, no, it's false. If it's false, it's going to tell you, no, it's true. It's just going to change its vision. It isn't going to change the current state. Okay. We can go and do the same thing as we have had in the for loop, and just like the previous one, add another variable here and check if it's true or not. I don't know if I do it or not, because it's just the same as in the for loop. So I'm not going to do that. I'm going to do it in the easy way. But if you wish to do the same thing in the for each loop or for each with break, yeah, it's easy. You can just go ahead and apply another local integer here, just the way I did it in for loop, and everything is just the same. The thing is, let's just go ahead and fix it. Well, what does this false tells me? This false tells me that at least one of these conditions have failed, and it tells me that we have received a break condition here. We have received a break order, and or we have passed the valid range for the loop index. You may say, well, if I receive a condition check here, a break condition here, and but I'm inside the valid range, it's okay. All I need is to just quit. But if I'm not in the current range, only for this condition, I need to reduce this index, because it has assigned it by 1, increased it by 1, and it falls, it doesn't actually decrease it again. So for only this condition, you may say I need to decrease it. But in fact, for all these conditions, I need to decrease this array index, loop index, and in a second I tell you why. Let me just do that. I'm going to assign it false, completed. Have this one here, and subtract it by 1, and check loop body, just like that. Loop 2, and assign it here, here. Oh, sorry. You can loop it break 2. This here, this here, and goes here. I think this is from 0 to 9, and plug it in here. without the break. Let's check it. Now I have the correct value. Let's just add a break condition as well. You may say, well, I can check add an event tick here and plug it to this break condition here and check, for example, for certain conditions that break the loop. But it's not going to work because actually the loop pattern, the loop algorithm, the loop graph is going to fire all its loops, all its cycles at one frame almost. And it's so fast, but the event tick is going to check it per frame. It's way slower than the cycle speed for inside the loop. So it's not a proper way to check the conditions. You need to use the loop body itself. To do that, I need to add a sequence here, here. We're going to, when down B, you can have a branch condition and check for the index and see, let's say equal 0 to, let's say for example if the index is equal to 7, if it's true, go ahead and break it. Let's compile it and just put it here. Well, it's correct now. You can see we have 7. We should have 7 because the 7 loop has just ran and it gave me the 7 index, and then it's going to check it. Yes, it's true, and now it's going to break it. So it tells me don't go for the 8 index loop. So as you can see, I don't need to check only for this condition because whether it is, even if we are in the valid range, it's again going to increase it by 1. Even if we are in the valid range, it's going to again increase it by 1, and it's going to give me the wrong index again for the completed. So I don't need to check only for this condition. For the false, whatever it is, I need to just go ahead and decrease it by 1. Or you can follow the previous pattern I just followed from this extra variable here and do that way, but it's harder. I don't suggest you do that. So we have just fixed this as well. So now let's go to the other one, which is I don't need this for each loop. Actually, for each loop is just fine, but here for each loop 2. Okay, it's just fine. But the thing is, actually, I don't know why they have assigned this extra variable. As I told you and showed you, we can just fix it with a very simple assign note here and decrease it by 1. So we don't need this extra variable. We don't need this more complex graph. We can do it a very simple way. So I'm going to just go ahead and remove this counter, like it here. Remove this variable at all. This one here. I'm going to assign this one by 1, and I don't need this one neither. Just go ahead and do it. And all I need is to just, for the false condition, add another assign here by holding down Control and W. You can copy and paste the node, plug it here for the complete, plug it here, and decrease this array index by 1, and we are just fine. We should again have the same functionality. Let's just check it. I need to go for each loop 2. Let's just compile it then. Check it. As you can see, we still have the same value, the same output result. Save it. Okay. Now for the for each loop with break. Let's go and check this, and let's do the same thing for this one. We don't need this extra variable as well. It's extra, actually we don't need that. So let me remove it and do it in a more simple way. Let's remove this loop counter at all, don't need that. Let's plug it in here. And check this one here. And this assign. And there, and okay. Should be just fine for this one as well. And oh, sorry, just forgot to have the assign for the false. And should be just fine. We'll just go ahead and check it. Register with break. Okay. Two. Oh. For each loop with break. Index completed, and I'm going to check this one and see. Yeah, again we get the right result, and let's go ahead and check for the break condition. We have to do the same thing here. Add the sequence here. Here, this one here, and branch come here. True comes here. The condition is from the index. And say